Question number 4. The question is about acids, alkalis, and bases. A student reacted zinc oxide powder with hydrochloric acid to produce zinc chloride solution. 4.1 is an AO2 question. The student need to apply the knowledge, and this question is associated with the required practical number 8 in combined science. Complete the equation for the reaction by writing the state symbol. This question is from the state symbols and soluble salts. If you look back in our question, zinc oxide is a base, it is not an alkali, so it is unable to dissolve in water. HCl, when dissolved in water, it becomes hydrochloric acid. It means that that is soluble in water, and we will get the solution of zinc chloride. So zinc chloride is also soluble in water. So we need to write the state symbols. Zinc oxide is insoluble, so it is in powder form, so it is solid. HCl can dissolve in water to make hydrochloric acid, so it is aqueous solution. AQ. Zinc chloride make a solution, mean soluble in water, so write AQ, and water is in the liquid form, L. 4.2 is an A1 question from the required practical number 8, and the topic is neutralization and soluble salt. Give one way the student could speed up the reaction between zinc oxide and the hydrochloric acid. So we want to make the reaction faster between zinc oxide and hydrochloric acid. The speed of the reaction can be increased by heating the mixture or by increasing the concentration of the hydrochloric acid. Let's see the model answer. The model answer is by heating the mixture, the speed of the reaction can be increased, or by increasing the concentration of the acid, mean HCl, the rate of the reaction will increase. 4.3 is an year 1 question from the required practical number 8, and this question is from the limiting reactants, neutralization, and the soluble salt topics. How could the student know when all the hydrochloric acid has reacted? As it is mentioned here, the hydrochloric acid was the limiting reactant. So hydrochloric acid will finish first and the reaction will stop. As the result of that, zinc oxide will remain in the powder form and it will not react anymore. Let's see the model answer. When the hydrochloric acid reacts fully, then the solid zinc oxide will not react and remains in the solution. 4.4 is an year 1 question from the required practical number 8 from the topic of neutralization and soluble salt. How could the student obtain zinc chloride solution from the reaction mixture when the hydrochloric acid has reacted? We know that hydrochloric acid has reacted fully and there are the particles of zinc oxide still present in the solution which are in solid form. We have to separate zinc oxide from the solution of zinc chloride. We need the filtration process to separate zinc oxide from the solution. Let's see the model answer. The model answer is filter out the solid zinc oxide which is unreacted or left behind in the solution because all the hydrochloric acid has reacted with zinc oxide, or the students can write the filtration process can be used to remove zinc oxide from the solution. 4.5 is an A1 question from the practical activity number 8, and this is from the topic of soluble salts and neutralization. Describe how zinc chloride crystals are produced from zinc chloride solution. After filtration, we have the solution of zinc chloride. So zinc chloride is present in the solution. We need to heat the water, or we need to heat the solution. The water will start evaporating, and we shouldn't let it to get dry. So when a little bit water will left behind, we will stop heating and will leave the crystals for overnight. And when all the water will evaporate, we will get the crystal of zinc chloride. Let's see the model answer. The model answer is heat the solution to evaporate water, not getting fully dried. Leave the crystals to dry overnight so the water will evaporate and crystals of zinc chloride are left behind. 4.6 is a combination of AO1 and AO2 question. Sulfuric acid, which is a strong acid, and sodium hydroxide, which is a strong alkali, react to produce sodium sulfate. So it is actually the neutralization reaction. Sulfuric acid is gradually added to the solution of sodium hydroxide. The pH of the mixture changes as the sulfuric acid is added until in excess. Suggest the pH at the start before the sulfuric acid is added and at the end when sulfuric acid is in excess. Sodium hydroxide is a strong alkali, so it lies in this region, sodium hydroxide, and I drew the pH scale here having the range of 0 to 14. So sodium hydroxide is in the range of 12 to 14 because it is a strong alkali. Sulfuric acid, on the other hand, is a strong acid, so its range is coming here in the range of 0 to 3. The student can pick any value from 12, 13, or 14 for sodium hydroxide, that is initial pH, and for the sulfuric acid, when it is in excess, then the pH will be in this range, that is from 0 to 3. So at the start, student can take any value, and at the end, student can pick any value. This is my sulfuric acid, H2SO4. I will write the range for the student, that is from 12 to 14 from sodium hydroxide and 0 to 3 for sulfuric acid. 4.7 is an AO2 question. Complete the symbol equation for the preparation of sodium sulfate. You should balance the equation. So we have sodium hydroxide and we have sulfuric acid. When sodium hydroxide reacts with sulfuric acid, it makes sodium sulfate. And I elaborated this equation as here the sodium is existing in the form of sodium ion Na plus and OH as OH negative. This sodium is going to combine with this sulfate, and we know that sulfate has a charge of 2 minus, sodium has a charge of plus 1 only. It means we need one more sodium. So we need two sodium ions with one sulfate ion. We are making sodium sulfate Na2SO4. So the salt, we are first of all we are going to write the salt. The salt is sodium sulfate Na2SO4. It is a neutralization reaction, and we know that as the result of neutralization reaction we will get water, H2O. It is a simple equation we need to balance. We know that there are two sodium and there is only one sodium, therefore we need to multiply left side with 2. Let's see how many moles on the left and right side. 2 sodium, 2 sodium, 2 and 2, 4 hydrogen. There are only 2 hydrogen. On the right side we need to multiply by 2. After multiplying, we need to check again. 2 sodium, 2 sodium, 2 hydrogen and 2 hydrogen, 4 hydrogen, 2 times 2, 4 hydrogen, 2 oxygen and 4 oxygen, 6 oxygen, 4 oxygen, 2 times 1, 2 oxygen, altogether 6 oxygen, 1 sulfur, 1 sulfur. So the equation is balanced. 4.8 is an AO3 question. A solution of hydrochloric acid had a hydrogen ion concentration of 1 mole per dm cube. So it is a 1 molar solution. Water was added to the hydrochloric acid until the pH increases by 1. It means that the water is added, so the solution will become more diluted. And the key information is given here. The pH will increase by a factor of 1. What was the hydrogen ion concentration for the hydrochloric acid after water had been added? Whenever the concentration is changed, the pH value is either increased or decreased by 1. The relation is given here. The concentration is increased or decreased by factor of 10. The pH will increase or decrease by 1. The initial concentration is given 1, and we know that it increases by 1, so it means the concentration is reducing. If you assume that for the concentration of 1 mole per dm cube, that the pH value is 2, when we divide it by 10, the concentration will increase by 1 number, it will become 3. So it is 0.1 mole per dm cube solution. The pH will increase by 1 number. So the correct answer is 0.1 mole per dm cube.